Again with the optimizations. So now we've got a wooden beam that has a rectangular cross-section area of height h and a width w. And the strength S of the beam is directly proportional to the width and the square of the height. Now what are the dimensions of the strongest beam that can be cut from a round log of diameter 24 inches? Okay, well now, first things first, let's go ahead and draw a picture. Alright, so I've got a beam, and I've got a width, and I've got a height. Okay, and now my strength S of the beam is directly proportional to the width and the square of the height. Okay, so directly proportional means one goes up, the other goes up. And so S is directly proportional to the width and the square of the height. Now, if you haven't had algebra in a while, when something is proportional to another, that means that there's just one simple constant, that's called the constant of proportionality, that relates the two. And so it's very, very typically registered as K. So S is equal to then KWH squared. It says, what are the dimensions of the strongest beam that can be cut from that diameter? Okay, well, from a diameter, or a log diameter 24 inches. Okay, well, let's go ahead and kind of give this a logish feel here. Try to enclose this in a circle. Not a very good one, but, you know. All right, so now we say, well, what's the maximum, or what are the dimensions of the strongest beam? Well, obviously we want some height and width on this, and we want it to be as big as possible, as far as taking up as much as a log as possible. So from one corner to another, this is going to be the diameter of the log. Okay, you're just going to cut the largest rectangle you can out of this thing, and that's the idea behind this. Okay, so now we have something that we can work with. We know that that with our strength here, that we want the strongest log, which means we want to take its derivative. I'm going to go ahead and do it this route, but we don't know what to take the derivative to. So now let's go ahead and see if we can't come up with a way to express this. And now I'm going to go ahead and try to express, let's say, log diameter 24 inches. Okay, so 24 then. 24 inches squared is equal to h squared plus w squared. So now 24 squared minus w squared is equal to h squared. That's pretty easy. I'm going to go ahead and I'm going to stick with that because I do have an h squared in here. And so I'm going to erase this. That wasn't the route I wanted to take. Not yet anyway. Okay, so now I've got an expression, so I can get all this into one variable. K, by the way, is not a variable. Not a variable. It is a constant. It is just a number. It is a known number, in fact. And that's how we treat that then in our derivatives. But first, we know that h squared is equal to that, and so we have s is equal to k times w times h squared, which is 24, which is 576 minus w squared. And so if we go ahead and expand this out, which I think is easier to take the derivative on, then we have k, we'll say 576 kw. Most people like the numbers out front. 576 kw minus kw cubed. And all I'm doing is I'm just simply distributing that across. So let's go ahead and take our derivative here so that we have ds to dw, our only variable, is going to be equal to the derivative of this first thing here, which is 576k minus 3kw squared. Okay, remember, the k is a constant. It is not a variable. I'll clean up this w just a tad bit here. All right, so we just drop this down just by our power rule. We drop this down in front, and then we decrease it by 1, and that becomes our 3kw squared. So we set this to 0 is equal to 576k minus 3k kW squared. So if we go through here and we look, there's a couple of different ways we can do this, but I'm going to do this in the most direct route that I can think of. Subtract 576K from both sides. Whoop, 576K. That goes away, and we have negative 576K is equal to negative 3KW squared. Okay, now when we do this, let's go ahead and divide by negative 3K. Negative 3K. And so we have now 576 divided by 3. This is where a calculator would come in handy. Oh, I happen to have one right here. So if we just take 576 and we divide that by 3, we get 192. Oh, that's handy. So we get 192 is equal to, and now the k's cancel, and so our constant proportionality really doesn't matter. And we get that is equal to w squared, which means that w is the root of 192, which I believe is not a nice square root. Nope, 13.85. And so this is w is approximately equal to 13.86 inches. And now I didn't carry the inches through, but because the 24 was represented in inches, that kind of set the units for the whole mess. Now, we need to go back and find h, but h is 576, so if we rewrite this down here, we have h squared is equal to 576 minus w squared, which is 192. And so 576 minus 192 will go ahead and give us 384, and we take the square root of that. So give us 19.5. Okay, so 19.60. So when we do this, we get h squared is equal to 384. Take the square root of both sides, and we get h is equal to the square root of 384, or 19.60 inches. And so there are the two values that we were looking for. Now, what are the dimensions of the strongest beam? Those are the dimensions.